Hey, welcome to today's Agronomy Minute with Mark. My name is Mark Glady, agronomist for WinField United in western Minnesota. And today we're talking about fall fertilizer, specifically P&K. It's late September, a lot of soybeans have come off, and a lot of our growers are asking about putting on fall phosphate and potash, and they're questioning, what about the nitrogen credit in my MAP or DAP or MES? Is it too soon to put that out there? Am I going to lose it? Is it going to leach? Is it going to volatilize? Just a lot of questions on the behavior of that nitrogen. So let's go through some scenarios and talk about what can happen to that nitrogen. So for easy figuring, let's just assume we're putting out 100 pounds of product, either MAP or DAP. We're going to get 11 units of N with the MAP, 18 units with the DAP. And if we also assume we're shooting for somewhere around 175 units of total nitrogen with our other nitrogen source to raise roughly a 200 bushel per acre corn crop, 11 units out of 75 is just under 6% of my total N needs needed for that crop. 18 units from the DAP, just over 10%. Still a small percentage of the overall nitrogen I need, but getting to be substantial and certainly something that we care about. We certainly don't want to lose that both economically or environmentally. We don't want to see that nitrogen in the water systems. But first of all, it is a small percentage of the total nitrogen we need, but that's the first thing to keep in mind. Now, if we take a step back and look at how that nitrogen behaves in the soil, I'm going to switch over to urea just for a second and talk about how urea behaves in the soil and how that compares to the nitrogen credit from our MAP and our DAP. So if you apply urea to the soil, the first thing that happens is that it converts over to ammonia, chemically the same as anhydrous ammonia. It's a gas, and if this urea is laying on the surface, or in anhydrous ammonia case, if we don't get good sealing behind the soil, behind the knives, this ammonia goes up into the air. We call that ammonia volatilization, and it can be lost. Okay, if we are putting out urea, this is where we talk about stabilizers to slow down the conversion of that urea to ammonia. An agrotane or an anvil are products that are going to slow that conversion of urea to ammonia, buy you more time to get it incorporated. Okay, ammonia, we got our ammonia in the soil. Ammonia, whether it's from urea or anhydrous ammonia, it's going to react with soil moisture. And even though we're really dry in western Minnesota this year, there still is moisture in water films around soil particles. There's more than enough moisture there for this ammonia to grab one hydrogen from water to make ammonium NH4. Ammonium is the exact same form of nitrogen that's in MAP or DAP. MAP and DAP are acronyms for monoammonium phosphate or diammonium phosphate, but it is ammonium. And since we're in the ammonium stage, we've gone past the volatility stage or past the volatile stage. We're not dealing with ammonia in MAP, DAP, or MES. We're dealing with ammonium. So if you got a grower that's busy combining beans and says, hey, yeah, go spread my P&K on that other field that I finished harvesting, but I can't get there for 3, 4, 5 days before I can chisel plow it in, that situation, you will not lose any of your nitrogen credit from MAP or DAP through ammonia volatilization. We're not in the ammonia form, we're ammonium. We're safe from volatility. Okay, point number 2. Point number 3, this ammonium in warm soils, assuming we do get it chisel plowed in, and if our soils are still in the upper 50s or 60s, which they are, because we're still in late September, or still in September, in several days or maybe a week or two, a lot of that ammonium will convert over to nitrate. And nitrate is the leachable form of nitrogen. Wherever the water goes, presumably down, that's where nitrate is going to go with it. Okay, the reason we talk about stabilizers like Instinct or N-Serve from a anhydrous standpoint or others is to slow down the conversion of ammonium over to nitrate. The ammonium sticks to the soil. Ammonium's got a positive charge. All soils have a negative charge to them. Ammonium wants to stick. Nitrate, negatively charged. Like charges repel. Soils are negative. Nitrate's very water soluble, where leaching can be an issue. So 2 different places for stabilizers, with the urea to ammonia, preventing that surface volatilization. But in the fall of the year, more importantly, a nitrification inhibitor blocking that step is what we usually look at. Okay, so the other question growers have, and the third point here, am I going to leach out my nitrogen credit? Again, a small percentage, only 6 or 10% of the total N needs from MAP or DAP, but can that leach out? Technically, it can. However, this year, western Minnesota, again, very dry. As a general rule, a clay loam soil in western Minnesota can hold about 2 inches of moisture or rainfall per foot of soil. 2 inches of rain in 1 foot depth of soil. And if we consider the top 5 feet, the general rooting depth for corn and soybeans, 5 times 2 gives us 10 inches of water holding capacity in the top 5 feet. We would need at least 6 or 8 inches of rain, maybe closer to 10 in some spots, between now and next spring, which isn't out of the realm of possibilities, but pretty unlikely, to totally saturate that top 5 foot rooting depth and then start leaching nitrate down out of the soil profile. Certainly possible, it can happen, but again, for a small percentage of our total nitrogen, to get it on now after harvest, get some good tillage done, the chances of leaching out the small percent of nitrogen credit that's in our MAP and DAP is a very minimal risk, and I feel very comfortable getting our P and K out this time of year when the weather's still nice. We can get good tillage done and get the seed bed or get the tillage done to get ready for next year's crop.